Hello, everybody, and welcome back to our class. In today's class, we are going to talk about midpoints and legs of heights. And we are going to show that these 6 points are actually on a circle, so they are concyclic. Well, so let's actually construct our triangle. Here's our triangle right here. This is vertex A, this is vertex B, this is vertex C. Let's also construct heights. AD is a height. BE is another height. And CF is another height. Well, we actually looked at this kind of setup where we were focusing on a triangle and its heights. And for example, we realized, and it's easy to prove again, that we have a bunch of cyclic quadrilaterals, namely AFDC is cyclic. No, just because of the fact that we've got these two right angles. So this quadrilateral being cyclic actually means that if we connect F with D here, well, the angle BFD, no, this angle is external to quadrilateral AFDC. That angle is going to be equal to angle C. So BFD is congruent to angle C. Now, what else is going on here? Well, if we connect F with E, we actually get another cyclic quadrilateral, namely BFEC. Again, for virtually the same reason, now angle F is congruent to angle E here, and they are both 90 degrees. And now what's going on here? Well, actually, angle C is an angle of this quadrilateral is going to be congruent to angle AFE, angle AFE being an external angle to this triangle. And this is all due to the fact that this new quadrilateral is cyclic, no? Which means that, for example, if we look at the angle EFD, the measure of this angle is 180 degrees minus twice the angle C. All right. Well, actually, this is all we need to know in terms of us proving that the midpoints and legs of heights are concyclic from the legs of heights perspective. So now, for example, if we take M to be midpoint of BC, well, what we get now is we can look at a right angle triangle, which is BEC, and EM is going to be the median on the hypotenuse of this triangle, no? Well, so there you go. Here's our EM, right? Well, and just because M is midpoint here, well, triangle EMC is isosceles, no? So triangle EMC is isosceles, which means that actually the external angle DME is actually the sum of the two angles that are not adjacent to it, which are equal to each other, and they are equal to C. So this is twice the angle C now. And this is another important relationship of ours, because now from these two relationships, 1 and 2, so 1 and 2 imply that the quadrilateral FE MD is actually a cyclic quadrilateral just because in this case, we've got the sum of two opposite angles is 180 degrees. So FEMD is cyclic, which means that we just figured out that given the orthic triangle FED, well, midpoint M is on the same circle with points F, D, and E. So this quadrilateral that I'm highlighting now in blue, which is FEDM, is cyclic, no? Well, in the same fashion, we can prove that the other two midpoints of sides AC and AB are going to be on the same circle. So I leave that as a little homework for you. All right. So the conclusion is that the legs of the heights of triangle ABC and the midpoints of sides AB, AC, and BC are cyclic. Thank you very much and see you at our next class.